Hey, what's up? This is Christian, and this week has been pretty interesting to be honest. Um, I started school and I've been working on my other projects as well, and I've kind of noticed a significant difference in my programming. It doesn't really feel like, since I'm grinding and I've been watching a lot of tutorials, it doesn't really feel like I've made a lot of progress. But since I've been in class and I've been collaborating with other students and the professors as well, I've noticed that my level of knowledge I've gained over this past month. I looked at my YouTube channel and it's been 28 days since my first post. So it's been about a month since I've been on this project, and I've noticed a huge difference. I didn't realize how much I had learned, how much I had been learning, and honestly, it really excites me. It makes me excited for what's to come and see how much I can grow. Alright, so we're going to jump into these. Day of the programmer. Given year, determine the date of the 256th day of the year. Okay, 89%. For an easy one, that's kind of, this is a long explanation. She invented a time machine. Wow. The day of the programmer is the 256th day of the year. Okay, I didn't know that. During a year in the inclusive range, 1700 to 2700. So it's a century range. From 1700 to 1917 was a Julian calendar. Since 1919, they use a Gregorian calendar. The transition from Julian to Gregorian calendar system occurred in 1918, when the next day after January 31st was February 14th. What? That's weird. This means that in 1918, February 14th was the 32nd day of the year in Russia. Okay. In both calendar systems, February is the only month with a variable amount of days. Okay. It has 29 days during the leap year and 20 days during all the other years. In the Julian calendar, leap year is divisible by 4. I should honestly be writing this stuff down. Where's my notebook? Oh, here it is. Yeah, no, there's a notebook here, but these are like my Python notes. I need those. So, where is it? So the Gregorian, February 14th is after January 31st. So 32nd day, 31st day. So Gregorian also divisible by 400. So I'm going to write the modulus 400. And then modulus 4. But it's not divisible. How do I do not divisible? Can I do a not modulus? Oh, okay. I can do the modulus and then go not equal to 0. Okay. Given a year Y, find the date of the 256th day of the year of that year according to the official Russian calendar. So we're going by the Russian calendar. Weird. Okay. During that year, then print it in the format day, month, year. Okay. For example, given the year 1984, it's divisible by 4. So the leap year, so it's a leap year. The 256th day of the leap year after 1918 is September 12th. Okay. So, we're working with kind of a lot, to be honest. Okay, let's see. Let's look at some of these explanations. Sample, but 2017. So it's 31 days. February has 28 days. March 31. April 30. Okay. It's a leap year? No, it shouldn't be a leap year. It's not even. I mean, I was learning about daytime in Python. It's still kind of, looking at this, still kind of throws me off a little bit. It's just strange. And I've been working with Python a lot lately. Yesterday I spent almost the entire day watching Python tutorials. And I got a lot of good practice in as well. Let's see. I mean, an easy way to do it would be to import datetime and then use what's it called, the datetime theta or delta theta. I don't know I forgot what it's called, but essentially it gives you it allows you to calculate the number of days past days past a certain point. So if you wanted to know the date a week from today, you can use that theta to calculate that. But I don't think that's the most optimal way to program this, and I don't think that's what they want us to do, to be honest. So I have a few ideas of how to do this, so here's what I'm gonna do. I think the best way would be to hard code the days of the month. So let's see. We can make a global variable. I don't know if I have to write. No, I don't have to write global. We'll do int. Oh man, I forget you don't have to do that. Days of month. So start with 0, and then we'll go, 0, and then we'll go 31. Oops. Sorry. We'll leave this one blank. I wonder if you can do that. This will be a good test. February, March, April, May, June, July, August, September, October, November, December. Okay. I mean, honestly, we'll just start from here. The next 0 is January. It's a little confusing, but it'll work. Okay. So they enter the year. If the year, so the leap year, it has to be divisible by 400. And is it and or? Let's see. Either, so it's or. Which is strange because I can't think of almost any scenarios where I guess in the case of the 100, yeah, there's not many scenarios where it's divisible by 400 and not divisible by 4. Modulus 4. Put this in parentheses. So it has to be year. It can't be divisible by 100, which is a really weird variable, but that is what they want. I think I need this, right? Okay, so that looks good. Let's put a colon here. So we have this. This sets us up for a leap year. So if all this is true, that means it's a leap year. So we'll go days of month at index 2. No, sorry, 1. That's too confusing. I gotta do it like this. So we'll start at 1. Equals 29. Else it's sorry. I guess in most cases I could default this to 28. Okay. So we'll change it in the case of a leap year. So go while we need to create a variable actually. So to keep track of the, why is it like that? To keep track of what day we're on. So we'll go int day of year. Let's start with 0. So while day of year is less than 256, I don't know if that's the best way to do it. Because watch, check it. This is what I was thinking, but it's not gonna work. Because once it becomes greater than the day of the year, it's gonna break out of this while loop. And we're gonna be stuck with a value that's greater than what we're looking for. And since we're not keeping track of the month we're on, yeah, there's a bunch of stuff that's not gonna work here. Okay, so we'll do this instead. No, I do like this actually. We'll do it like this. I'm not gonna copy this again. Well, that's weird. We'll initialize an iterator out here also. Month equals 1. So here we'll go month equals month plus 1. I don't know if this works. I don't like writing that like this. It just feels unnecessary. Oops. So the day of year, so we'll add days of month at the at this specific index. Okay. I don't know why I keep writing int when I'm using Python. It's a hard habit to break. I'm gonna tell you that. Okay. Okay, so we're going through this, we're adding this to this, we're iterating through month. So when it breaks out, we'll go day of year minus equals so yeah, we'll subtract it by the month, and then we'll get what is it called? Programmer day? Day of the programmer. We'll do 256 minus day of year. I don't know if this is gonna work. I'm kind of nervous. Okay. So we do this, and then we'll go. It's gonna come out really weird. Okay, we just gotta send it. Okay, so now this day of the programmer, or 256. So this is gonna give us the number of days into the current month that we're in. So we'll do a print statement, do an F, and then we'll put the year here, then a decimal. What the format? No, it's day, right? Yeah, day, month, or month, day, year. So the year's gonna go at the end. So go like this. So we'll go month. Month minus 1, because we're in a different month. Dev programmer. And then the year. So I already know for sure that this is gonna require some padding, since they want it in day form. I did see a tutorial on it, but I can't remember how to do it. So let's run this. It should work fine, to be honest. I might have some compilation errors like usual. This OR doesn't work. Is there only one? I've actually never used an OR statement in Python. Funny. Oh my gosh, dude. So right now, I'm programming. I haven't started anything in one of my classes, but I'm programming using Java, Python and C right now, so I need to learn to, what's going on here? Int? Where's int? Line 13. Something's wrong. In line 13. Okay. Oh, this one. I never set this equal to 0, so it's just like, yo, I'm doing this math, but I'm expecting a Boolean. So it's still not working. Int object is not callable. So year. What kind of inputs are we looking at? 1800, okay. So the year goes here. With these parentheses, I'm not sure what's going on. I was actually coming into this really confident. I was ready to go. Just one end. And did I delete the other end? Oh, did I not put an end? Oops. Alright, so we made progress there. Line 34, there's something wrong. So when it calls it results, oh, did we not return anything? Are we supposed to? Yeah. I'm guessing we return this as a string. That's not right. Oh, am I supposed to? So when I do this, it makes it into a dictionary. But what I want is a list. There's so many like small differences between each of the programming languages. It's actually pretty strange. Hey, there we go. We got it to compile, that's good. Unfortunately, the answer is completely wrong. Oh no, it's close. I just switched the day and the month. Okay, that's not bad at all. And we're off by a day as well. So I guess we don't count the first day. Which, I don't know if that really makes sense. Okay, so we need to figure out how to do that padding. I want to say I have a file, but I really don't want to go through my documents just in case I end up revealing some personal info. Something I need to work out. Leading 0 in Python. zfill and the width. Okay, that's really simple. I don't know if I do it in here though. Can I? I don't think I can. Let's try. .zfill 2. Then we'll do the same thing for the month. check it. Hopefully this works. I kind of doubt it though, but we'll see. Yeah, see? It does not work. Int object has no attributes, zfill. Okay. So what if I do it outside of here? Like that. Since technically this in here becomes a string object. This might work. But no, I don't think it'll work. It'll just print out zfill. Int object has no attributes, zfill. Okay. Okay, so we gotta try something else. Yeah, this is for type string, I believe, yeah. Okay, here we go. There's a lot of info on here. And I'm not really seeing anything. Thing 0, oh. A hidden mystery revealed. That's not what I was looking for. Literally at all. So let's see what we got here. Yeah. Yes. Print %02D. Percent is like printf or okay. So do it like that. So if I enter the variable directly in here, oh, here it is. Printf 1 colon. This is the num. So if I do it like that, is that gonna work? I don't know. Alright, let's check it out. I'm kind of nervous. Not gonna lie. Okay, check it. Hey, it worked. Wow. Just gotta delete this zfill. So I gotta remember this. That's really, really interesting. I really like these F strings, to be honest. The way it was, there's another way in previous Python versions that it went over in the tutorials I was watching. It's the the dot format method. So instead of having the variable directly in here, we'd have just these empty brackets and then whatever format we wanted. So this would be in here. And then after that, we would have a dot format. And it honestly gets really confusing as you add more and more things, especially with dates and times. And I don't know, dates and times I guess is pretty consistent, but if you're working with other variables that didn't necessarily have a standardized format, or it's just confusing. But doing it like this it looks really clean. You know, I really understand what's going on. Let's see. Expected output, your output. Okay, so we're getting the wrong day. And I'm already subtracting by 1. See what happens when I don't subtract by 1. Am I gonna get 14? Yeah, I got 14. Expected output was 13. Something's going on here. Let's see what happened with the one I did right. Just subtract by 1. It's kind of a quick fix, if I'm going to be honest. So 13/9/2017. Okay, so that's not a leap year. 1800. Is that a leap year? Let's see. It should be a leap year, to be honest. Ouch. So 1800 divided by 100. What is divisible at 100? So it should not be a leap year, right? But it looks like in my calculations I did make it a leap year, which is not what we want. So we'll do a print statement. See what we're getting for is leap year. Okay, so put in some random custom inputs. Put this year, since is it a leap year? Yeah, it is leap year this year. So we'll run the code, see what we get. So it shows it as not a leap year, which is incorrect, because it is leap year, right? Let's see. How do I clear? So it's not divisible. And not divisible by 400. So it shouldn't be a leap year. So I guess that's, according to this Gregorian calendar, it's right. Let's see. 1800 should be that, yeah. Since 1800 is a leap year per the Julian calendar. Wait, what? Hold up. Are we doing Gregorian or Julian? Now I'm confused. Given a year Y, find the date. I don't really understand what's going on here. Down here, the explanation is 1800 is a leap year. As per Julian calendar, day lies on the 12th of September. So this is saying that it is a leap year. But when I calculate this, I'm getting one day off. Wait, that still doesn't make sense. So there honestly shouldn't be that many variable days. So 256 days, should there be the 12th or the 13th of September, right? 12, y equals 2016 is a leap year. Okay. So 2020 should also be a leap year, no? but it's not considered a leap year. I don't understand if we're using Julian or Gregorian. So anything before 1917 is the Julian calendar. Okay. Okay. I get you. So anything before 1917. So, so keep this for now. So if the year is less than, was it 1917? Is less than 1918. Wait. So the transition was in 1918. So, is this divisible by 4? It is not, but it is considered a leap year. Confusing. Okay. So we do it like this. This. We'll do this. If I do an OR statement up here, we go OR. Or the year equals 1918. And then we'll go in here, or so no matter what. Okay, so this should be good right here. So this or this will go in here. So this is Julian calendar. Is that how you spell Julian? It is not. It's with an A. Julian calendar. And then this other calendar. How does it work again? The Gregorian. Where is it? Oh, 400, 100. So this one's fine. There it is. Dude, I couldn't remember how to do that. Almost choked right there. If I do it like this instead. So the initial test will be this. We'll do it like this. And then this will trigger it to enter. Because this is true for both situations, right? So now if the year is less than 1918, or less than or equal to 1918, how about that? Yeah. Wait, it won't even enter though. Oh shoot. This or. Where's the or? Or the year. Okay, so then we'll go on here. That's good. So then we'll copy the rest of the stuff. We don't need this anymore. We don't need this anymore. This isn't necessarily true though. So we'll go like this. And this will be or. So if the year is not equal to 400, then it's not gonna happen. I guess this is only for years that are greater than. Greater than 1918. If the year is greater than 1918 and this equals that, this doesn't equal that. So this all has to be true. Absolutely. This is kind of hard. 89%. Okay, so then we'll do that. If this is true, and this is true, and this is true, then this will be this. But I want to make a continue. No, I'll break actually. Does this break out of everything though? I don't know. We will find out. Okay, so this is a new, a new edition, Julian calendar. And don't write this as, oh wait, dude. Okay, check it. So the year, so in here we'll enter if it's divisible by 4 or the year is 1918, because that's the only exception for this, because it's not divisible by 4, right? I did the math, right? Yeah, so it's not divisible by 4. So this is the transition year. So we'll enter here. The year is greater than 1918, which doesn't include this. We need, so if this is true, then this has to be true, and that has to be true. Then we break. So now we'll move on. And this isn't true. So true if that's true, or this is true, then we don't want to do this at all. So if it's not divisible by 400, then it'll be false. This whole thing will be, I want the whole thing to be false. We just want the whole thing to be false, to be honest. So if this is true and this is false, it'll break, and this is false. Oh no, wait. If this is true, okay, which is weird. Okay, so we're doing it the opposite. So if this is false, or if this is true, okay. And yeah, okay, this makes more sense. So this is gonna be an or. So the year, if the year is not divisible by 400, this will be false, and this will be, I mean, what if this is true though? That's the problem. So if the year is not divisible by 4, this is true. Okay, yeah, that's good. And the year is divisible by 100, this will be true. Okay. Then we'll break, hopefully, out of this whole thing. Start going here. Let's see what happens. Kind of nervous. Here. Oh, I need a colon. I'm actually really bad at putting these colons. Okay. We didn't change too much, to be honest, so it shouldn't be a break. This is literally the worst way to do this. It's gonna work, but it's... Oh my gosh, what's wrong? My days went off again. Oh god. So, let's run the code in my brain. So it's 1800, right? So we'll test here. $1,800 divided by 4. Modulus 4. Check. Modulus 400. Modulus 100. So modulus 4 is the only thing that needs to be true for 1800, correct? Correct. So if it's divisible by 4, or the year equals that, so it should enter here. Boom. Day of month 2012. It's gonna be 29 now. I said it. Okay. If the year is greater than, this is not true. So this whole thing should be false. Boom. So boom. We'll get day of year. The month is 1. And then we iterate through and we add to the day of year. Boom, 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 boom. And then the month, we'll increment by 1. Okay, so we break out of this loop. Boom. So we gotta subtract that by that. The day of the year, day of the programmer, minus 1. Okay. Does that make sense at all? I don't think it does. So What if I take this out? What if the day is correct, you know, for whatever reason? Boom. So now they're all wrong. Completely and utterly just wrong. My output is always 14. So I'm getting the same answer for all of these. Let's see. Okay, so do a print. Print this. Not leap year. Print this as leap year. No, I'll print down here actually. I'll just print here. Leap year, not leap year. Let's see. Oops. That should be fine. It's not printing anything. Kind of irritating. Yeah, why is nothing printing? Bro, is it not entering here? Oh no. Let's try again. Ooh. It's not entering at all. Doesn't make sense. It should equal 0, right? Yeah. I don't know what's going on. So the year is 1800, correct? That's what we're entering. Yeah, so we get this strip, whatever, year. We put that in here. Yeah, so it'd be 1800% 4. So we're getting this, but we're not entering it here at all. So what happens if we delete this? So run this. So in this situation, it does enter. I delete that. Why? Oops. So it's an or statement. If one or the other is true, so this is going to be false for this situation. Well, for some reason it doesn't even enter. Why though? Something wrong with my operands. Is it like a Python specific thing? Let's see. Because they're acting really strangely. Something I'm not used to. Okay, let's see. Is it operands or? No, what is it called? It's not true. It's true. Whoa, that's weird. Okay. So that's not right. Oh wait, no, it is right. I mean 0, 0, 0, 1, 1, 0? 0? I don't know what that means. Copies a bit to the result if it exists in both operands. And logical and or logical or. Comparison, okay. No. Right? Still no. Logical. There we go. Print X and, okay. I have to write out and. Is that right? Well, let's see what happens, I guess. Oh my gosh. How have I never run into this problem? Oh my gosh, that's so dumb. That's actually hilarious. I didn't know that. That throws me off so much. I can't believe that. I can't believe after all the tutorials I've done in Python, I somehow didn't notice or simply forgot. Because it had to have come up at some point. There's no way. There's no way. I'm still getting it wrong. Is this -1? How off am I? It's not the -1. Or is it the -1? It might be the -1. Well, we got closer. 2016 is so wrong though. So let's run through our logic. So we're getting 13, but it wants 12. I should honestly write up here. Okay. Something's up with there. 2016. Oops. Might be Julian's calendar. Alright, so print. We'll print the check. And then we'll get this leap year. We'll put is leap year, sorry. And then here we'll go like JK. JK, Mabi. It's essentially meaning that it's not a leap year. We initially thought it was, but it's not. Alright, so let's run that, see where we're at. So we're going JK MIB. That's where we're at. So it changes it back, but it actually is a leap year. So let's run through it. So 2018 or 2016, sorry. So it is divisible by 4. Put a check there. So we answer this one. That's good. So it is greater than 1918. So is it... Okay, so what are we doing again? 2016 divided by 400. So it's not divisible by 400. Okay, I think I see what's going on here. So it's either the following. It's either divisible by 400 or divisible by 4. And not divisible by 100. Which kind of doesn't make sense though, because divisible by 4 and not divisible by 100, but it is divisible by 400. So every 4th decade or century, the century, I don't know, whatever 100-year range is. I think it is a century. No, yeah, it's a century because the millennia is 1,000 years. Okay, so every century, every 4th century, it's true. Okay, so the way I'm doing this is kind of dumb. So it gets confusing down here, because it's this or it's divisible by 4. So let's change this. So it's divisible by 4. If you do it like that. If the year is greater than that, and that is true, then this entire thing should be false, right? So we'll change it back. So we'll test this first. So if this equals 100, then it's not a leap year, right? And then we'll go so if it's divisible by 4 for sure. Then we're gonna check if it's divisible by 100. Getting confused. I can see why this is an 89%er, which is still extremely high considering, but I'm struggling. I'm kind of blanking right now. So we don't want that to be true. So if this is true, then we'll enter here and change this. But if this is false, if the year is not divisible by 400, or we want this to be the saving grace, you know? We do it like this, or this is the saving grace right here, boom. Doesn't make sense. I shouldn't even fix this one though. Is that right? Let's try it. Wow, it worked. So I guess that kind of makes sense. So the problem was we weren't going in here if this was true, but in case that this is true, okay. That kind of makes sense. That was actually extremely stressful. I still have a lot of room to improve. Wow. You're just such a small gap in knowledge, or a small because everything about programming is so binary. I mean, it's literally binary, zeros and ones. Something so small. Just the fact that I was using bitwise operators rather than logical. I just threw the whole thing off, and I couldn't understand why. That's so funny. Yo, I'm gonna watch this like at the end of the year. Oh shoot, I'm still getting... There's 50 test cases? Wow. That's actually pretty crazy. Let's see what situation we're getting wrong. We got most of them right there. So 2,000... It's supposed to be 12. Okay, so let's check this out. So it's probably gonna get 13. Okay, so let's run through it. 2,000 divided by 4. Okay, it is divisible by 4. And then 2,000 divided by... So if it's divisible by 4, it can't be divisible by 100. So that should be false. And then it's also divisible by 400. So that's going to be 0. Boom. Oh wait, shoot. Sorry. 5, yeah. Okay, so in this situation, it should be a leap year. But we'll run our print statements again, just to be sure. Run our code. So we're going JK, Mabi. So it's not a leap year. So theoretically that should be correct, right? But the expected output is the 12th, meaning it is a leap year, which is extremely misleading because it was to my understanding that it shouldn't be a leap year. So after this, we're strictly using the Gregorian calendar. So Gregorian calendar, I'm gonna look at this again for the 100,000th time. Leap year are either of the following. So divisible by 400 or divisible by 4 and not divisible by 100. So it's one or the other. Not, I guess you don't need to test both. So one of them is true, then you're good. So if it's divisible by 4, we should be gooch, right? So actually, now that I think about it, what if we do this right away? Let's try this out. We do this right away. Watch. Oh shit. Oh no. Okay. We'll do this right away instead of down here. This is only being tested in this situation right here. I'm thinking this should work. I don't know what's going on. 2000. So it is a leap year. My calculator didn't say it's not a leap year. But it should be a leap year because it's divisible by 400, right? Yeah. Is that or that? So in both situations that is true. Oh, okay. I see what's going on. Let's see, how can I fix this? So the problem is that we're testing for this, and if that's true, it's not supposed to be a leap year. So these two are true, it answers here. I want it to be, these two are true. Let's see. Not or? Do they have a not or? And not. Is that gonna work? I don't think it's gonna work, to be honest. Let's see. Not year. Wait, what? No, that's wrong. I guess not is not bitwise. Okay. So we wanted to exclude this situation. So if this is true, then I guess we can if we do another nest? Do it like this instead. 1918. So this is true, then we'll enter. No, it has to be the 100 first, dude. So do the 100. And in the case that it is divisible by 400, is divisible by 100 and not divisible. No, that doesn't make sense. So if we're here, and it's greater than 1918, the year is equal to 0. It's divisible by 100. This is the exception to that. So it's like, yo, but if it's equal to that, then the leap year should be different. So we set it right away, and we change it. Change that to that. Something like that. Okay, so it is a leap year. Is that what we want? I think it is. Okay. Around 10,000. This was honestly insane. I struggled so much through this. It's kind of sad. Okay, so it's working again. It should be fine. There's one test case where it doesn't work. How? What is it? 1918. Okay. I can see that. Alright, 1918. It's a strange time, you know? Whoa. What? Oh, that makes sense. Okay. The year equals 1918. Then want to set this. It's gonna be really weird. To 14, I think. Because the first day of the month is gonna be 14, then yeah. Okay. So now, that should be it. That should be wrap. I like to thank all my fans for all the unconditional support during this extremely. I still got it wrong. Probably should have tested it. That's fine, you know. Stuff happens sometimes. So we actually want to set this to 15. It's cool. Whatever. No big deal. No harm, no foul. Okay. So I want to thank all my fans for all the unconditional support. I know I'm less than enthusiastic. Honestly, that was tough to get through. That was really difficult. It seemed like I just kept running into problem after problem after problem after problem. And I couldn't figure out why. You know, the logic was there from the beginning, but there were so many like weird situational things that came up. This was a good lesson, to be honest. Let me bring up this cam. Close out of this. This was a good learning experience, to be honest. It I mean, luckily over the past few days I've been I guess not luckily. It was a little bit more difficult for me to get through this because the past few days I've really been grinding a lot. I've been focusing. I've been using a lot of force to get myself to study more, to watch more videos, because I'm not accustomed to spending long periods of time studying and learning. But as I've the more days continuously that I do this, the amount of, I guess, willpower, motivation, ability to force myself decreases, especially if like the power behind it isn't aligned with my goals. Luckily, the power behind it has been aligned with my goals. Most of the stuff I've been doing lately has been Python related, which is what I want to do for my personal project, which I'm really excited about. It's going to get a little bit more difficult as the semester progresses, for sure, because a lot of the stuff that I'm doing for class, you know, I'm taking some strange classes like computer architecture, which is a very interesting class, but it's just not super applicable to a lot of the fields I'm going to be in. And then I'm taking another class, reverse software engineering or reverse software construction, something like that, which, I don't know, I guess it's interesting, but it's not super aligned with what I'm doing. So when I'm doing homework for those classes and I'm going to be trying to do well, it's going to be tough, you know, because a lot of the power behind it isn't aligned with my goals. I mean, it's aligned with the goal of getting a degree, but it's not really super aligned with the goal of my bigger picture of, you know, really what I'm into, what I'm trying to do with my future. So that's something I'm going to need to be conscious of and keep in mind while I try to get everything done. You know, I'm going to have to make decisions, maybe make some sacrifices. We'll see where it goes. So I was going to wrap things up. Thanks for sticking through all this. This is going to be a really long video, but I'm glad I grinded through it, and I'm going to look forward to watching this in the future when I'm crushing it. Peace.